Welcome everyone to Water Savings with Every Flush, the new toilet tech. This course is approved for 1 hour in continuing education units, and that also includes LEAD AP Homes, BD+C, and O&M, as well as AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. My name is Brett Little. I'll be your moderator today. I'm here with the nonprofit, the Green Home Institute. And the question we're really going to be asking today is, how can toilets save more water, more than they already do? And so that's what we're excited to be focusing on, and then how that fits in with green building certification. We'll cover that, and LEED certification at the end of the session. And then also real quick, a huge thanks to our session sponsor, Niagara Conservation. With some of the lowest flowing toilets on the planet, we have glowing reviews from multifamily affordable housing specialists who only spec these to save water and for their durability. So a huge thanks to them and their support. And a big thanks to our secondary sponsor, Water Furnace, geothermal, ground-powered, ground source heat pump energy that can be used to help get your projects to net zero. And it's the most energy efficient HVAC on the planet. So check them out as well. All right. I am really excited to introduce today's speaker before I hand it off. Richard Rossi. He serves as the National Account Manager of New Construction for Niagara. As a longstanding knowledgeable member of the architecture and new construction communities, Richard focuses on expanding and developing business in the new construction market with a focus on multifamily residential and hospitality projects. So with that, Richard, I am going to hand it over to you. Welcome and take it away.
Thanks, Brett. Appreciate it. Get this going here. Hey, everybody. Thanks so much for tuning in. I'm Richard Rossi. Thanks, Brett, for the introduction. Sounds like you had some pretty exciting sessions coming up. I'm really interested in the NGBS session on September 30th. That's going to be pretty cool. So I'm going to try to log on to that. Hey, so thanks again for tuning in. I'm Richard Rossi with Niagara. I'm based in Austin, Texas. That's where I'm speaking to you from today. Hope everybody is out there is doing well, staying healthy, staying safe. As Brett mentioned, we're going to talk about toilet technology today. Niagara is a company whose mission really is, innovative technologies and plumbing fixtures. So we'll really focus on our toilet product today, but the technology that's in the tank of the toilet and how important that is to the toilet's performance. So there's obviously one thing that's really important on this planet, and that is, saving water. It's a very, very finite resource on this planet. So we're going to touch on some of the ways that we track, droughts and water shortages globally. And then we're going to talk about toilets in particular. Some real simple stuff like the heights of toilets, how that's changed, some of the design features that have changed over the years, how that GPF has been lowered and mandated due to water conservation and sustainability goals. And then we're really going to talk about the toilet's performance and how that's measured and how toilets are rated for water use and performance. A low flow toilet fixture in particular, is not really effective at doing what it's supposed to do unless it performs very well on the flush performance side. So that is really critical. So as we talk about water use and water use reduction, there's some things I really want to get into. But Niagara, as a company, has really been focused on this mission since our inception in 1977. The company was created and founded by Bill Cutler. And Bill's still involved in the company, as is part of his family as well. But our mission has always been, water conservation based, but also no change in human behavior, right? When you flush your toilet, you expect it to flush, you expect a clean bowl, and you're saving water without even thinking about it. So we're all about not changing human behavior, and that's how we base our, the technologies that we introduce in the marketplace. So. And this technology we're going to talk about today, the vacuum assist toilet, Actually been on the market for 9 years. So it's not a new technology, it's a proven technology in the marketplace, as Brett said. So here's just a little details on the AIA and ASPE CEUs, and Brett touched on all the others. So I did talk about Niagara, and we can kind of skip right to the meat of this. But one of the things you'll see on this slide here is that 0.8 GPF. That is very important. The vacuum assist toilets are able to get that flush volume down to 0.8, so just over 3/4 of a gallon, without sacrificing the performance of the product and the flush performance, removing waste and water from the bowl. So, and that's me. I think you can see my video as well. But if you need to reach out, that's my contact information. And Brett did cover my my bio. So on the water use and water use reduction side, supply and demand of water. You know, we all know water is a 3/4 of this planet. 70% of our planet is made up of water, but only 1% of that water is able to be used for human consumption. And we're sharing that among industrial uses, environmental uses, domestic uses, commercial, residential buildings. I mean, and we're using water in ways that we really don't even think about. Like now, for instance, with the pandemic that we're all experiencing, we're using more water to wash our hands. People are paying more attention to personal hygiene than they maybe have in the past. You're supposed to be, singing happy birthday twice when you wash your hands. So, we're using water in many different ways. The population on this planet has doubled over the last 50 years, but water use during that time has actually tripled. So, we are using water in ways we don't even really think about or consider, even in personal use, like, shutting the water off when you're shaving and taking shorter showers and all those simple things. The fact that we're using water the way we are really highlights the importance of using water efficient fixtures. We're going to be talking today about water efficiency programs as opposed to like a drought resiliency program. But as I mentioned, water is, and we all know it's a finite resource on this planet. So, and then the other thing to take into account on the water use side and reducing water is the cost. The infrastructure that delivers water and moves sewer throughout this country, especially in areas that we're experiencing huge population growth, like Austin, Texas, being one of those markets. It's the infrastructure is aging throughout the country. So all of those costs eventually get passed on to the individual water user, the developer that's developing a property, etc. So there's big impact fees and things like that developers have to concern themselves with, and so it's really important on the financial side too. And we'll take a look at some examples in multifamily and commercial construction of how important that is to keep the water use down in the building. So, and I do want to point out, I know there's a lot of perhaps designers online, architects, specifiers. You guys can make a huge, tremendous impact by specifying water efficient fixtures on your projects. I mean, we as individuals can have a few water efficient toilets in our homes. Putting, a couple hundred of those in a building is very, very significant to help us move forward with and save water for future generations. And that's what, water efficiency programs are all about. So on this slide, pardon me, this USDM map on the left is put out by the University of Nebraska at Lincoln every week, every Thursday. It's interesting here in Texas, South Central Texas, we've been experiencing severe drought conditions this summer in most areas of our state, Austin included. This map comes up on the weather report every Thursday morning when it comes out, and they just talk about how droughts move throughout the country and how it's impacting our area regionally here. So this is just a way that utilities can track droughts, apply water restrictions when droughts are anticipated, etc. But This is an interesting area of the country. We go here in Texas from flood to drought pretty quickly, and drought to flood pretty quickly. But I used to live in Las Vegas, Nevada. So in Nevada, that may not be considered a drought. We only got 5 inches of rain per year out there, but here we get regular rainfall. But if you go 8 weeks without rainfall, it's considered drought conditions, and water restrictions get put in place, et cetera. So important way to track how droughts move throughout our country. And then the map on the right is a World Resource Institute map, and this just shows water stress by country over the next 20-year period. And you can see there's a big part of the globe here that is in high or extremely high category. Those are all the red and dark red areas. This is measuring the ratio of withdrawals to supply of water. And this takes into account, plug in a lot of data on socioeconomic data on population growth and climate change and things like that. And, we see where we are, and you see, all of the United States in that high category, 40 to 80% of ratio of withdrawals to the supply of water. So the point being, this problem is not going to go away. Water is going to continue to be a finite resource on this planet. And we're going to continue to have to look at water efficiency programs and long-term solutions to save water for future generations. You can probably see by my webcam that I'm not a spring chicken anymore. I got a lot of gray hairs, but I do have adult children, and they don't have kids yet in my case, but we really need to focus on where our planet is. Not only for the extent of our lifetimes, but for our future generations as well. It's critically important. So on the residential side, we're going to look at water use, and this is a study done by the federal government, by WaterSense, by the EPA, and we will touch on WaterSense later, WaterSense labeled fixtures and WaterSense ratings. But for this slide, I want to mention to you that you can see here that the toilet is the largest indoor user of water. About 24% of your water indoor water use is from your toilet fixtures. So you can make a huge impact. A lot of people think it may be the showers or your faucets, even your indoor appliances like your clothes washer and your dishwasher, but it really is your toilet on average. And the toilet is flushed on average 5 flushes per person per day. We're probably even doing more of that now. More people are staying home and flushing your toilets even more. But that means in a family of 4, you're flushing your toilet 20 times a day. The other important thing I want to point out on the study is that about half of the leaks from your indoor fixtures come from your toilet. And most of those are attributable to the flapper style technology that's inside the tank of that toilet. When you take the lid of a tank type toilet off and you see the technology that's in that tank, that is really an important part of how the toilet is going to perform, not only on the flush performance side, but also on the maintenance side. Maintenance is very significant. You get into multifamily properties where there's hundreds of toilets. It's a big, time-consuming, cost-consuming maintenance issue, changing the rubber flappers on toilets. So we're going to elaborate on that a little bit more about the flapper style technology and how there are better technologies out there as far as the water conservation goes in toilet performance. But you can see about 30% combined with your leaks of your indoor water use is coming from your toilet fixture. So on the multifamily side, I just attended a webinar yesterday on multifamily construction and the state of multifamily in 2020 and going into 2021. And it is multifamily construction is still booming. Although, there's been a bit of a hit. Rents are being adjusted now, and construction's still going on. I mean, I look at Austin, and we've got high rises downtown going up like crazy. 1/3 of our population lives in multifamily construction currently in the United States. That's continuing to grow. So it's a very important sector to consider for water conservation. You can, as I mentioned earlier, you can make a huge impact in a multifamily building by specifying water efficient fixtures. And whether the owner's paying or whether the tenant is paying and the building is sub-metered, it's still really important. If the owner's paying the water bill and the wastewater fees on a building like an affordable housing project or student housing, senior living even, they're facing 100% of that cost, but the tenant doesn't have a huge financial incentive to conserve water. So it's important to have water conserving fixtures in that case. And if it's tenant paid, that tenant experience is very important. It actually inhibits the owners of the buildings from charging higher rents if your utility costs continue to go up. And then the last bullet point here is tiered rate structures. I think we've all experienced those in most utility companies. Once you reach a certain amount of cubic feet, gallons of water per billing cycle, your rate goes up. So there's an adder that's turned on. So that's also important to consider from a financial standpoint, to keep that water use under that additional adder that the utility companies are going to put on for water use in your property. So on the commercial side, commercial and institutional buildings account for 17% of water withdrawals from U.S. water supply. So, and all of those facilities other than restaurants can be attributed to the domestic restroom use. So replacing those toilets is a little bit more costly than changing out your aerators or changing your shower heads, but toilet replacement does deliver the highest ROI and will definitely pay back, especially when you go to a 0.8 gallons per flush. So briefly with energy and water, the thing I really want to point out here is that energy efficiency and energy conservation has been really at the forefront of our sustainable design and how we're doing our buildings. A tight enclosure and healthy indoor environments and good AC systems, all related to energy efficiency. Water is sometimes taking a back seat. But one of the cool things about water and energy is they're definitely related. I mean, it takes energy to retreat water, and water itself is a resource that can be used, collected, treated, and reused. So, and there's technologies being developed today that are able to flush toilets with gray water, which I think is another great way to save water on this planet. So, why are we peeing in perfectly clean, drinkable water? But it is really important to consider that tie-in between water and energy, and by saving water, you're actually saving energy because less energy is required to retreat that water. So we're going to get into a little bit of toilet talk here. We're going to talk about flush toilet design. One of the first things that people don't even think about really is what the material the toilets are made out of, and that is called vitreous china or porcelain. Some folks call it the same product. Toilets are manufactured from this material because of its ease of being molded into shapes. Its resistance to abrasion, its resistance to water and chemicals, etc. But a fully glazed ceramic material, a fully glazed china, is definitely preferable for water efficiency, especially on the interior portions of the toilet that come into contact with the water, the bowl, the trapway, etc. So fully glazed ceramic is an important part of the toilet's efficiency, and it also helps keep the toilet bowl clean, which is another thing that people get concerned about when you start talking about low flow fixtures, is how clean is that bowl going to be after every flush. So we're going to touch on some of those the aspects of the bowl design later in the presentation. So simple stuff you all might know about. Everybody knows about a little bit about toilets, but a two-piece toilet is what you see here in the center picture. And that is a toilet with a separate tank and bowl. So the tank is attached to the bowl with fittings. It's a very common toilet type of a tank type toilet, a two-piece. One of the reasons is, the tanks, the tanks and the bowls ship separately. So it's more economical than a one-piece toilet, which you see here over on the left-hand side. But a lot of people like this one piece as well. It is all one fixture. There is not a tank separate. This is a tough cleaning area here between the, yes.
Hey, I'm sorry. The slide you're showing is showing some details about commercial, but it doesn't have any images on it, just so you know.
Oh, sorry. I wonder if it's not advancing. Did y'all see the slide on the glaze ceramic?
No, no, it's just stuck on commercial right now. So
Well, different toilet configurations, one piece or two piece. Ease of cleaning is one of the things that is important with a one piece toilet. There's not a gap between the tank and the bowl. So that's one of the reasons people like the one piece. And then also that enclosed trapway is something that is preferred for design and ease of cleaning as well, versus an exposed trapway that you see in the two-piece toilet picture there. The other toilet I just want to point out is again a floor-mounted model, which is a rear outlet. So there's an extra loop in the trapway that's going to outlet the waste and the water into the plumbing system in the wall as opposed to the floor, but it's still mounted on the floor. There's also wall-mounted toilets these days, which are very common as well. The technology we're talking about today isn't currently available in that wall mount yet, but perhaps feasible in the future. So Holly, you can flip it to the next slide, and thank you.
Yep, Richard, just real quick. I mean, what's the, if it's easy to describe, you know, what is the technology issue of wall-mounted?
Well, the biggest issue really is the flush mechanism, which we will look at later in the presentation, and just getting that in the wall, because it's not a, you know, it's a little bit big to put in a wall. So that's been the biggest thing as far as building a wall-mounted unit, about Niagara manufacturing a wall.
Okay, thank you.
Thanks for the question. Okay, Holly, are you able to flip the?
Yes, we are. Are you able to see the height slide?
No, just see size.
No, but still stuck on. So is yours not moving either, Holly? It looks
yeah,
like.
mine's not moving either.
Wow. Okay, I've never experienced anything like this before. I'm gonna. Oh, there it goes.
There it goes. Okay, cool. Height, yeah. The height of toilets has changed over the years too. Now, if you guys have ever used older toilets, you can absolutely tell. You feel like you're going to fall into them. But the height difference really is only a couple of inches. Toilets used to be produced at 14 to 15 inches in height without the seat. Now most toilets are produced at what you see here, 16 or 17 inches from the floor to the front edge of the bowl. And that is considered comfort height or chair height. So big difference in the comfort of sitting on an older toilet that's much lower to the ground. This also contributes to ADA compliant height as well, which is with the seat is 17 to 19 inches in height. So you add another inch to that, and both of those toilets, or all of the toilets actually pictured here, would be ADA compliant height, 17 to 19 inches. The only other thing I really want to point out on this slide is the rough-in dimension. And that is the dimension from the wall to the center of the flange bolts where the toilet is mounted to the floor. So common dimensions you see there, 10-inch and 12-inch. But it's important when designing a building to consider the rough-in dimension to the plumbing outlet in the floor. And Holly, you can flip to the next slide. Thank you so much. Cool, that flipped right away. That's good. Hopefully you all can see what I'm seeing. The trapway of the toilet is the area behind the toilet bowl that moves the waste and the water between the bowl and the plumbing system. So you can see the toilet on the right there is picturing an exposed trapway. The toilet on the left, I mentioned that one piece earlier in an earlier slide, that is an enclosed or skirted trapway. So really it's a design feature, really doesn't affect the functionality of the toilet itself because there is a trapway. beneath that enclosure. And there's always access. You can see that little door there, that little pop-out unit, access to utilize the flange bolts to tighten the toilet to the floor. So, but it's also very much easier to clean. I mean, a lot of these toilets are preferred in like hospitality type environments because it actually saves time in cleaning the rooms to the point where you can really save the labor cost to do that. So again, it's more of a design feature, but it is something to be considered depending on the type of project that you're speccing the toilet for. And you can flip, Holly, thank you. Excellent. It's moving quick now. The flush handle positioning is also something that's important, not only for ADA compliance, but design-wise and convenience-wise as well. So several different types of flush mechanisms on a tank-type toilet. The swing lever, of course, people are very familiar with. It's going to be on either the sides of the tank or the front side, but left and right. Set either on the left or right side. And then the push button technology, which is on the top of the tank, is becoming very popular, as is the dual flush, which is pictured on the left there. One of the keys to the dual flush technology, and it's great, I mean, even with a 0.8 toilet, you can take that half flush or that liquid flush down to 0.5. So half of a gallon and 0.8 on the full flush. With the technology we're talking about today, the vacuum assist. But again, it's got to be user friendly. You see that raised green half flush button is an easy way, even at night, to realize that you're liquid flushing or half flushing the toilet. So it's just another way to cut down water use. But I have seen dual flush toilets on the market that are very difficult to operate, where you can't tell if you're half or full flushing. So what's the point of having that type of button if it's not user friendly? The other thing I want to point out on the single top flush, that there's a number of different factors that go into ADA compliance, one of which is accessibility of the flush handle and the amount of pressure it takes to actuate the flush valve and to actuate the flush itself. And that push button center tank is actually an ADA compliant accessibility button. Some people think it has to be the swing lever on the sides, but the single top flush, as long as it's centered in the top of the tank, and you can actuate the flush with a certain amount of pressure, that is an ADA compliant button. So, and you can switch to the next slide, Holly. Thank you. So, as we're gonna talk a little bit more about how toilets are tested for GPF and for flush performance. So that is literally, how many grams of waste the toilet will flush in a single flush, tested in a laboratory environment. So we're going to talk about that. And then we're going to talk about the flush technology that's inside that tank, which is critically important to the toilets, the GPF, the amount of water it's using, but all gallons per flush, but also on that flush performance side. So you can go ahead and flip, Holly, thank you. So regulations and testing, and you can go ahead and go to the next slide. We're going to talk about a few of those, just touch on ASME and IAPMO. ASME is the American Society of Mechanical Engineers. That all toilets sold in the United States must comply with ASME standard A112.19.2. And there's also a separate standard for the dual flush toilet, 112.19.14. And then lastly on the slide, I want to point out that IAPMO is the International Association of Plumbing and Mechanical Officials. And really what they focus on is the safe and efficient water use in residential and non-residential buildings. For instance, IAPMO will do the testing for ADA compliance, for height, accessibility, for the amount of pressure it takes to actuate the flush on the toilet. So IAPMO will test for anything related to health, safety, and welfare. I'll go ahead and flip, Holly, thanks. WaterSense label. Hopefully you all have heard about this. It came into existence, really, it's a federal government program, voluntary partnership with manufacturers by the EPA. And this program was developed in the early 2000s. It actually went into effect really in 2007. But it is a label that indicates that a toilet is using 20% less water than a standard model. So that would be a 1.28 GPF versus a 1.6 gallon per flush toilet. It actually does save energy because it's saving water, and the performance is better than regular models. So there's actually a performance standard associated with that WaterSense label, and that is it must remove 350 grams of waste, solid waste, in a single flush in a laboratory environment. So the toilets are tested to failure. If the toilet passes, then it's going to get that WaterSense label. So as you can see in that bottom note, WaterSense has saved helped save Americans a significant amount of money. 3.4 trillion gallons of water, and it's somewhere over $84 billion in water and energy costs since it was launched in late 06, early 07. So, and we'll elaborate on some of these certifications on toilets in future slides as well. But the impact of the WaterSense label is very significant, both water and financially, water savings and financially. Holly, you can flip, please. Thank you. So we're going to touch on LEED. Brett talked somewhat about that. Is going to elaborate on this as well. But the LEED v4 WE category, I just want to point out that all newly installed fittings and fixtures must have this WaterSense label from the EPA for LEED v4 WE. So Brett will elaborate in a little bit more detail, but high efficiency toilets will contribute in ultra high efficiency, which is what the 0.8 toilet is with the vacuum assist technology that we're talking about today. That is going to contribute LEED WE points and LEED v4. So you can flip, Holly. So we're gonna take a quick timeout for quiz after our little technical difficulties we had moving these slides. But so how much water would anyone say if you want to take a stab at it? Either audio, whatever, you can type it in. How much water would you say an average toilet uses per flush that's out in the market today, installed and in use? Less than a gallon, a little bit more than a gallon, or as much as 3 to 5 gallons? Any responses? We'll give you a couple seconds to type that in if you'd like to.
We got one fishbowl.
Good answer.
I think they answered for everyone.
Okay, cool. Well, actually, Holly, if you want to flip the slide, it's actually a fish tank of water. So 3 to 5 gallons per flush. So the point being, there's a lot of water guzzling toilets still out there. I was on a project right before the pandemic hit in late February down in Houston, and it was an older building, but the toilets were a 5 gallon per flush toilets. And they were testing the 0.8 toilets, the vacuum assist toilets for that project, to pull those 5 gallon toilets out and replace with 0.8. We need to be doing more of that out in the marketplace because there's still a lot of water guzzling toilets out there, amazingly enough. So go ahead, Holly, and you can flip to the next slide. Thanks. And this is just it really explains the low flow toilet and the advent of low flow toilets and how it all went down in the late 80s. But back in my teenage days, the toilets were flushing at 7 gallons per flush. 5 gallon toilets were very common as well. And then 3.5 was a water conserving toilet, 3.5 gallons per flush. But in the middle to late 80s and into the early 90s, states began to adopt water conservation standards. It began to become a little bit more of an in thing to conserve water. People actually realized that, hey, we better start saving a little water on this planet. We're using it pretty fast. So that's when 1.6 gallon per flush toilets emerged, low flow or high efficiency toilets at the time. And the fact is that a lot of toilet manufacturers have produced a lot of 3.5 gallon per flush toilets. That was the common flush volume for toilets at that time. So what happened is the manufacturers modified the tank trim inside those toilets just to cut the flush volume of the water use in half, not doing any other design changes to the trapway, the bowl, or anything else having to do with the toilet. So what that caused a significant amount of consumer dissatisfaction at that time. As a matter of fact, people were going up to Canada to get toilets because the toilets, the 1.6 toilets that were available in the United States were really poor performing toilets. People got very frustrated, and thus water conservation wasn't that important to them. It was more important to actually be able to flush your toilet. So the key is with technology that how far we've advanced. I mean, if you see down at the bottom note, a couple bullet points there. There's over 1,000 models of high efficiency toilets on the market today, HETs and UHETs, and they actually outperform the older 1.6 and the higher volume use toilets, even 3.5 gallon toilets. So it's a matter of a technological advancement in the toilet industry. So Holly, if you want to flip. So some of the things really that came out of all that, WaterSense being one of them. Hey, we got to be able to rate these toilets for GPF and how much water they're using. But geez, we better make sure that they have some kind of performance standard associated with them, so that we can know that the toilet is working, so consumers can know the toilets actually will work with this amount of water. And it's amazing we still fight that stigma that people have about low flow under 1 gallon toilets. When we talk about 0.8 gallon per flush toilets, people are very, very skeptical that they're going to flush well. Thus, a lot of people test these 0.8s and they work very, very well. So that's how they've grown in popularity significantly over the years. But MAP testing is another, or maximum performance scale, is another way and this was actually created before the WaterSense, the EPA created WaterSense. This was created in 2003, early 2000s. And what it is, it's a MAP score. So a toilet is actually scored for the number of grams of solid waste it can remove from the fixture in a single flush. So it's actually done in a laboratory environment with miso paste or soybean paste and toilet paper combined, weighed out, obviously, to the number of grams, and it's a pass-fail test. So it gets to a certain point when the toilet doesn't perform on the first flush, it doesn't evacuate that amount of waste. That is the MAP score or MAP rating of the toilet. And I just want to point out there is a website for those interested. It's called map-testing.com. Where you can actually go and compare various manufacturers and models of toilets with the flush volume, the MAP scores, etc., and whether they are WaterSense certified or not. But in 2012, MAP came out with a MAP premium label. So this takes the WaterSense label to a whole nother level of performance and water use, reduction of water use. So you can see there the number one thing that is required to get the MAP premium label on the toilet is it has to be certified by the EPA. So it's got to have the WaterSense label first. It's got to flush with no more than 1.06 gallons per flush, so 1.05. So basically you're at a gallon per flush, just over a gallon per flush. And it does have to have a MAP score of at least 600 grams. So you can see that's significant. That's 170% of the demand on a toilet, more than what the WaterSense requirement is, 3 times the normal demand on a typical toilet. So you can see that MAP premium label is pretty significant for a high performance and low water use toilet. Holly, you can flip. Thank you. Awesome. So flush rating standards, this is just an example showing what I just explained. When there was no federal standard for toilets, for performance of toilets, and water use was cut to 1.6 by the federal government. And then we moved on to a MAP rating standard in 2003 and the WaterSense label, and then the MAP premium label. You can see where we are now. I mean, again, this is a testament to advancement in technology in the toilet industry. We have to get this MAP premium label, you've got to flush 600 grams and only 1.05 gallons of water. So significant changes in the performance standards of toilets over the years. You can flip, Holly, thank you. So drainline transport, there are a couple slides here we want to touch on, the difference in plumbing between commercial and residential buildings. One of the key differences is the presence of additional long duration water flows from other water sources in the building. So obviously in a residential building, whether that be a single family home, whether that be a multi-family or multi-residential type construction, you're going to have additional long duration water flows. It's going to help move the waste and the water down the drain lines, regardless of the GPF of the toilet. In commercial buildings, you may not have that. You're usually not going to have showers. You may not have the dishwasher and other types of water flows that are going to help the movement of the waste down the drain lines. So the other things to consider in commercial plumbing are the slope of the pipes. They're generally shallower pipe slopes than in residential buildings, larger pipe diameters, and then the amount of material that gets flushed down. Commercial toilets get much more abused than residential toilets. Toilet seat covers, paper towels, etc. So important to consider that. PERC did this study, Plumbing Efficiency Research Coalition, and determined that it's not necessarily recommend 1.0 gallon per flush or less in commercial applications with long commercial drain lines and don't have that additional long duration water flow to help push the waste and the water down the drain lines. The interesting thing about the vacuum assist technology we're going to talk about as we get to the end of the presentation here is that the power of the flush in that toilet comes from the trapway. It's a vacuum that's created in the trapway, so it's a pull force as opposed to using gravity and water to push the waste and the water through the plumbing system. So that vacuum creates a significant line carry on these toilets, considering the amount of water that's used in the flush, which is 0.8. So it's that power that's created in the trapway that's going to pull that waste down the out of the toilet and through the drain lines. Holly, you can flip. This is a similar study done by MAP. We just touched on MAP and the MAP scoring system for toilets performance and water use. Similar findings related to the proximity of the toilet room to supplementary water sources in the building and the larger drain pipes and shallower pipe slopes, et cetera, in commercial buildings. So, but the point being in new construction, in most cases, can accommodate ultra high efficiency toilets in a new construction type project. And in the next slide, we just talk about that and the importance of a plumbing engineer in these instances, especially if it's an older building with older plumbing, to do some studies on this and determine if a 1 gallon or under or ultra high efficiency fixture is appropriate for that building. And Holly, you can flip. So we're going to start talking about flush technology and the importance of that technology in cleaning the bowl. That's removing the waste not only from the bowl and into the plumbing system, but keeping that bowl clean is really important. Another complaint that people had about those 1.6 gallon per flush toilets when they first came out, converted from 3.5 gallon toilets. I mentioned the fully glazed ceramic. That's important for the water efficiency of the toilet, but it's also important in keeping the bowl clean. A non-glazed ceramic is going to be a lot harder to move and clean the waste from the bowl with the single flush. I want to point out on the center picture here, that is a side view of what the vacuum assist toilet looks like before it flushes. So that's a clear view of the trapway. You can see there's two water spots, one at the bowl level and another lower in the trapway of the toilet. And what that does, it creates a pressurized trapway in essence, so a siphon in the trapway. So when this toilet is flushed, it actually pulls that air up, and you can also see that connection between the trapway, pardon me, and the tank. That goes up into an air transfer tube, which we'll elaborate on in the next couple of slides. That is what creates the power of the flush. When that air is removed from the trapway and moved up into the flush chamber or into the air transfer tube, it creates a siphon, which is going to pull the waste in the water from the bottom of the bowl into the trapway, into the plumbing system. And then as that tank is refilling, it's going to force that air back down into the trapway and repressurize it after every flush. The photo on the right there is basically showing some rim jets, a rim wash system. There's various cleaning systems that go into the vacuum assist toilet that also help it. It's not only the power of the flush, but it helps utilize that 0.8 gallons to clean the bowl as well. And we'll examine those in the next couple of slides as well. Thanks, Holly. Thank goodness you're here with us today. Appreciate you. So gravity-fed toilets and pressure assist toilets. These are just some of the other tank-type toilet technologies that are on the market. Quite a bit different between these two. Sometimes people have trouble differentiating the pressure assist from the vacuum assist, and I'll help explain that as well. But gravity-fed toilets basically have a chain mechanism and a flapper of some type in that tank. I'm sure you've seen this type of toilet before. I've been in the toilet business, like when I get at the hotels or whatever, I'm going to take that tank lid off and see what the technology is inside the tank of the toilet. Unless it's got a Niagara label on it, then I know what it is. But in any case, the gravity-fed toilet is strictly that. It is using the weight of the water and gravity to push the water to create the power of the flush. So when that flush handle is pulled, that flapper is going to lift up and it's going to drain the tank of water. And again, it's gravity and the push force of the water, the weight of the water that's going to give you the power of the flush. On a pressure assist, it's a similar process, still water pushing, but there's actually compressed air inside that cylinder that's inside the tank. And then it's going to push the water even faster into the bowl and through the trapway, creating a powerful and yet loud flush. So these toilets, you know it when you use them, they're very, very loud when you flush them. But again, it's a push technology using water to push the waste in the water.
Richard, I recall on, if you're going to talk a little bit more about pressure, I'll let you go with it then, sorry.
Sure, yeah, and anytime you want to hit a question, please do it. Holly, you can go to the next slide. We're going to talk about a couple other technologies here. The gravity-fed toilet with flapper. You can see that cutaway there. This is a very common residential grade toilet. In a lot of cases, you're going to see this in apartment buildings. You're going to see this in your own home. It's got a rubber flapper that's attached to a chain mechanism. When the toilet is flush, it's going to pull that flapper up. You do not have a 360-degree water flow. That flapper in some way impedes that water flow. That's going to the water is going to flow from the tank into the bowl to create the power of the flush. This is a faulty system at best. The rubber flappers require significant amount of maintenance over time. They're going to become worn. They're floating in the water. They're exposed to water constantly. They're hooked up to that chain, which gets caught up sometimes. And then they do require a lot of maintenance, as I mentioned, so they're going to be changed out on a fairly regular basis, whether it be, a homeowner doing this or doing the maintenance crew doing it in a multifamily property. And generally, you're going to go out to the hardware store and you're going to get a non-OEM flapper, a red corky, or whatever you find at the hardware store. And the fact is that those flappers could be using up to 3 times more water than the OEM flapper is rated for. So again, it is a push technology. It's a gravity-fed toilet. Open that flapper, gravity and the weight of water create the power of the flush. On the right is a tip bucket technology, and that's cool. You can advance, Holly. So all the water you can see there is contained in the bucket, in the tip bucket. So it's a little bit less likely to leak this toilet because there's not water that's constantly coming into contact with the bottom of the tank. There is no flapper, so it is a flapperless technology. It does reduce maintenance costs, and it's a 1.28 gallon per flush. But when the toilet is flushed, you can see the bucket tips, and then it is gravity and the weight of water that takes effect. You do have a 360-degree water flow from the tank into the bowl, which is important for efficiency as well and power. But the vacuum assist technology we're going to talk about, kind of takes that to another level. And this technology, there is a cylinder in the tank, and there it is pictured. I actually do have a clear tank of the vacuum assist that I can show at the end of the presentation if time allows. But the inner chamber and the air transfer tube are the key to this technology, and I kind of gave you a little glimpse of that in a previous slide with a side view, but we'll elaborate on that in the next couple of slides. But getting that flush volume down to 0.8 in a single flush and as low as 0.5, 0.8, which is an average of 0.6 roughly, little over 0.6 gallons per flush on a dual flush technology with this vacuum assist, you can really get that flush volume down without sacrificing performance. So this is again a cutaway of the toilet and what it looks like inside the tank. The connection of the air transfer tube is important. I've had people ask if you can, retrofit this tank on an existing toilet bowl, and you cannot do that because of that connection to the trapway of the toilet. So part of the ceramic, part of the vitreous china has to allow that air to flow between the trapway and the air transfer tube. And we'll talk on the next slide about how the water and air move when it's flushed. The water spot is actually pushed up in the bowl as well. So normally with a low flow toilet, you're going to have a very, very low water spot in the bottom of that bowl. With these toilets, you're going to have commonly a 6-inch by 8-inch water spot. So that does also help keep the bowl clean. Now this is a good example of the cleaning system with the cutaway on the left. These toilets utilize a siphon jet at the bottom of the bowl, where the water is going to be pushed through the trapway to finish the flush. The siphon jet's a little bit smaller than most toilets, so it's going to force that water even faster into the trapway of the toilet. There's also a rim jet on the front of the toilet, and all these are going to be covered up, obviously, when you purchase the toilet or when it goes to a job site. But this is what's underneath the cover of the toilet bowl. So the rim jet is going to force that water down into the trapway faster from the front of the toilet bowl. And then the rim wash system I pointed out earlier on an earlier slide also helps keep that bowl clean. So it's a matter of utilizing the 0.8 gallons very efficiently in the power of the flush, but also to finish the flush and keep the bowl clean. And you can see on the right picture there, if you want to go back real quick, thanks, the pre-flush and post-flush levels. A typical toilet, as I mentioned earlier, is going to be gravity forced. So it is actually going to drain all the way to the bottom before the fill valve kicks in and the toilet fills back up. These toilets do not. It's only the water within that cylinder, which is 0.8 gallons, that's used in the flush. So you can see your pre-flush and post-flush levels there. It flushes fast, it flushes quiet, and it refills very quietly. And the reason is that fill valve is a Fluid Master 400A fill valve, a very common part in the toilet industry, but it's actually modified to fill from the bottom. So you can see that is fully submerged all the time. So when these toilets refill, they are very, very quiet on the refill. I mean, you basically have to put your ear up to the side of that tank to hear the toilet refill. So most toilets are pretty loud on the refill because that fill valve fills from the top commonly, and you're gonna have to fill that whole tank back up with water. You can flip, thanks. Cool, so this is just a representation. In green is the air and blue is the water, and this is how the air and the water move. When the toilet is filling, the tank is filling with water. I just showed you that fill valve. It's gonna fill that tank back up to the full water line. In doing so, it's gonna force the air down that air transfer tube, and it's got nowhere to go except back down in that trapway again. So it's gonna reload or repressurize the trapway while filling. Once it's done filling, you've got a pressurized trapway. When you flush the toilet, it's going to quickly pull that air from the trapway into the air transfer tube, creating a siphon or a siphonic effect in the trapway, a pull effect in essence. So what's going to happen? It's going to pull the waste in the water from the bottom of the bowl initially before the water even enters the bowl. Most toilets, the water is going to enter the bowl first, and that's what's creating the power of the flush. The cool thing about these toilets, when we do a demo on these toilets with a clear tank at a trade show, for instance, we bring our own water, we bring our own pump system. We don't hook it up to plumbing or anything, but you can certainly see when the toilet flushes, the water spot in that bowl moves first before the water enters the bowl. That is that vacuum creating the pull effect and pulling the waste in the water from the bottom of the bowl first before the water even enters the flush. And then again, as it refills, force the air back into the trapway and reprime it for the next flush. You can flip, Holly. Thank you. So the dual flush mechanism is the same, except there is an additional cylinder in that in the flush chamber. And when you hit that raised green button that we saw earlier, that is going to be a half flush. So that is going to shut off one of the cylinders for the duration of the flush. It is spring loaded, so that seal is held for a few seconds, and then it's going to pop back up, so you can use a full flush on the next flush. But similar movement, obviously, of air and water, just that extra chamber allows for a reduction to half water use when that raised green button is hit. And you can flip, Holly. An example based on a 3-person household, average 5 flushes per day. We talked about at the beginning of the presentation. This is just a representation of how much water you can save on an annual basis in a 3-person household. Upwards of 20,000 gallons, over a 3.5 gallons. So there's still a lot of those high flow toilets out there. We got to get some 0.8s out there to help save this planet and help cut your water bills down pretty significantly, enough to save a swimming pool's worth of water in a 3-person household in a year. And then we're going to just look at a couple quick case studies of retrofit jobs. Very easy to identify the cost savings on when you have existing toilet types at 3.5 gallons per flush, and you go in and retrofit. This is a hotel project in Phoenix. The owner, frankly, was very reluctant, Mike Patel, very reluctant in doing this with the 0.8. Obviously, like I mentioned before, it's that concern that the toilets are not going to flush properly. I was on a retrofit job here in Austin. It was a huge apartment complex, probably 300 toilets, and they were just they were right in the middle of pulling the toilets and putting the new 0.8s in, and toilets were laying all over the property. But I talked to the office manager, and her biggest concern was, it was an Odin Hughes was the developer actually, and did a great job with water conservation. But she said, man, I'm going to have to hire another person, to answer the phones, because the toilets aren't going to flush. I love what Odin Hughes is doing, but what kind of complaints are we going to get when these are 0.8 toilets? And I explained to her about the technology, and never heard from her. I said, you call me if you get any complaints. But very common with these toilets. People very rarely complain about the performance, if ever, because they work so well because of that technology. But you can see the financial savings and the water reductions in just the first billing cycle, pretty significant. And you can flip to that next case study. One thing I want to point out about this case study, it was supplemented. The cost of this retrofit was supplemented by the Coachella Valley Water District in California. And a lot of utilities are doing this. They're supporting homeowners, they're supporting developers, they're supporting hotel owners like Marriott by financing. They finance 50% of the cost of these toilets, 890 toilets on this project. And you can see that estimated cost savings of 15 million gallons a year, changing out those 3.5 gallon toilets to 0.8. I'm very familiar with this hotel. I've been there, I've eaten dinner out. There's a restaurant out by that lake where you take that little boat there out. But it's a cool property. My parents live close to this property. But Coachella Valley Water District is responsible for really helping Marriott financially with this retrofit. And you can flip to that last slide, summary. Water is a finite resource. We have to be cautious about how we use it. You know, one of the ways of doing that is to implement water efficiency programs and using water efficient fixtures. The real key though is how they perform. You know, there is really no point in utilizing a water efficient toilet if you have to flush it multiple times to get it to flush. Really defeating the purpose, and you're frustrating the owner as well. So, and then, you know, can save a lot on maintenance costs with the flapperless design too. But we talked about the waterless, the rating systems, the WaterSense and the MAP Premium label, as far as, you know, how you can identify a toilet as a consumer, as a specifier, to be water efficient and high performance on the flush. And then, yeah, as we saw in the last slide, you can save a lot of water by using water efficient fixtures like this. So thanks, Holly, appreciate it. And that's the end of my portion of the presentation. And thanks, Holly, for saving me on the technology side. Appreciate it. So I'm gonna let Brett take over, and then if we have some time, and this is really cool stuff. So I want you to, everybody to pay close attention to this, because this is stuff I can learn a lot more about as well. But I'd love to have the opportunity to show you the clear tank vacuum assist toilet if we have the time to do so. Thanks, Brett.
Yeah, hey, thank you, Richard. So yeah, real quick, we're going to go through how this more in depth connects with LEED, and then can you stick around for some Q&A? I know we're a little bit over, but can you stick around?
Yeah, absolutely. Yep.
Yeah, great. So so real quick, you've got the LEED. Hopefully, you can see my screen. LEED credit library here. And on this LEED credit library, I've got on the left there the LEED for Homes program, so you can see total water use and indoor water use. And then on the right, you can see the commercial program. If you open up the same credit library under water efficiency, indoor water use reduction and indoor water use reduction for points. And then here, we're going to talk a little bit about existing buildings or O&M, operations and maintenance. And so you can see V4 on the top there, water performance, or I'm sorry, V4.1 water performance on the top. On the bottom right, just straight up regular V4. They have a little more complexity to regular V4. Indoor water use reduction for just like files B, D, and C. So that's if you pull it up and you want to read more about those credits. So here is a couple things you need to know. Performance versus prescriptive. So the reality is energy modeling has become normal. So we do performance all the time for energy. Water is going to be the next level. And LEED has really taken off with this. And in some cases, I just learned this morning, only allows performance. They don't even allow prescriptive anymore, other than in homes. And so really it gives us this ability to determine how we want to save water in our LEED projects and put our resources where it makes most sense for us, versus a mandated prescriptive forced pathway, which tells you what to do. So I get really excited about performance, and these types of high performing toilets actually do much better in performance, as I will show you. So LEED for Homes, this is the LEED workbook. I pasted a link to it in the chat, and then those of you watching this in the future on demand, you should have the handout. So if you go to the WE tab, and you'll see you'll scroll down to the WE credit indoor water use prescriptive pathway. Now you'll see for regular V4, you will see single family on the left there, and then you will see multifamily down on the bottom right. Both for the prescriptive pathway require you to get a point for the toilet. You need to be at least 1.1 gallon per flush or less to get a point now. So they're pretty aggressive, but it's just 1 point, single family or multifamily within the prescriptive pathway. So if you have 1.28, you get no points here. And as you can see, the technology we talked about during this session clearly blow this out of the water, if you will. Now V4.1 is still in beta for single family, but I can tell you if it gets past the way it's currently written, they have extra credits for 0.8, so that's already written into the LEED system ideally for the single family rating system under 0.1. But we didn't bring it up here because it's not balloted yet, so it's not approved, but it is something you can use for single family. Now let's talk about water performance. So Lead for Homes has introduced water performance, something brand new under V4 and V4.1, and you can see the water reduction calculator tab there. That's an optional pathway. And here I went down to the toilets and I put in one of these high-performing vacuum assisted technology dual flush toilet, 0.9 on the high side, 0.5 on the low side, and then we put in a single flush on the 0.8 side. So we just made up this imaginary project. Let's imagine a mixed-use, mixed-income, multifamily development with 25 high-end 3-bedroom homes and 20 low-end 1-bedroom homes to serve low income. So we put the single flushes in the low income side because there's always a lot of concern about that. We hear it all the time. And then we put the super lower ones in the 3-bedroom one. You can see here on the system. This is just an example, so you can download it and see it. And then over here on the right, you can see here's the baseline assumptions, 9,000 for design, or for the design, 9,000 gallons compared to the baseline, 24,000 gallons on the 3-bedroom home, and then 4,000 compared to 9,000 on the 1-bedroom. And then you can see if you go further down, that yields a 57% savings in water over the LEED baseline just on the toilets, right? So this document didn't have anything else. We just did toilets and we're already at 57% savings. So you can see LEED performance, if you take the performance pathway, requires a 20% savings in water. So we're already blowing that out by about 37%. And you're picking up 10 points. Again, we haven't touched outdoor waters. We haven't touched shower heads, aerators, water sense appliances. We just did toilets. And we're already blowing the requirement out of the water. And we're at 10 points, which, by the way, is getting you 1/4 of the way to just getting LEED certified just by putting in these super high-tech toilets that work, that we know work. And also showing you that it's much better to use, if you're using this better technology, you don't want to take the prescriptive pathway. You're only getting 1 point there, no matter how low you go. You could be a 0 water and you'd still only get 1 point. So performance is really the way to go. It's what we recommend, and we're super excited about performance pathway. Now let's get into LEED Commercial. Now LEED Commercial is a little more progressive than homes. They don't even have a prescriptive pathway anymore. You have to go total performance. So here is the LEED water use reduction calculator. Here's a link to it. We can share that with you. It's easy to find. And it's similar to the homes one, but much more complex because you have to try to figure out use patterns within commercial buildings. So it makes me happy that I work in homes. Just like residential, you have to hit a 20% on LEED, BD, and C at your bare minimum. And then here's just a snapshot of what we shared with you. We made an imaginary project that assumed 50% female, 50% male. Apparently there's use patterns there that reflect in this made up commercial property. And so you can see we made an assumption of a dual fuel toilet, the 0.9, 0.5, which averages at about 0.7. And you can see here just alone, the baseline for LEED is 1,116 gallons. And with these dual fuel high-tech toilets, we're at 51,000 gallons. And that yields, again, about a 56% savings in indoor water usage. And again, just on the toilets alone, haven't touched any flow rates of anything else. And then here, the same calculator spits out LEED V4 operations and maintenance on the existing buildings program, and using the same technology, we're at a 63%, again, just on the toilets, water savings using this calculator, which you can download. Now, if you're doing LEED V4.1 operations and maintenance, it is 100% driven by actual performance. It's not based on modeled performance like LEED for Homes and LEED BD and C. So here's a really cool YouTube channel, and it's powered totally through the new ARC platform, which is free to use. And so you're going to upload your water bills into ARC, And in theory, your water bill should be super low by using this technology. But I'm showing you, this is where you're going to put your water bills in ARC. And then ARC is going to spit back a bunch of performance metrics. And so here you can see from this video, here's the water performance score. Now, I did talk to USGBC and I said, look, what if we're trying to estimate the savings of toilets, for example, in this case? How do we do that? Well, they said you can use a performance tool like this one or like the WERS index or whatever, and you can just make some assumptions on what the water bills will be before the construction starts, and you can put it into ARC to see how it will perform before you start and see where your score is going to be so you can make the most informed design decisions. But ARC is in lead O&M is totally now based on V4.1 actual results. So you really have to achieve these savings, just so you know that. So I wanted to leave you with that. So that's it on lead. I'll let you guys get to your questions now. Before those questions come in, make sure to check your inbox for your certificate. Make sure to take that survey that pops up when we close out. The same one will be sent to you an hour later. For those of you watching this on demand in the future, click on that YouTube link on our website. Go down, click Show More on the left there. On the right there, click Need More CEUs, and then click on the direct link to access the quiz. Take the quiz with an 80% passing rate. And as always, a huge thanks to all of our top tier sponsors, Mitsubishi Electric, Build Equinox Serve for smart ventilation, Rheem for heat pump water heaters. All of these help you build better and make a more sustainable home. So with that, Richard, let's take a look at some of the questions we might have in right now. Do you know of situations where rainwater or gray water have been used in conjunction with UHETs? If so, is there a recommendation for a degree of filtration of the water used for these high flush technology toilets?
Yeah, great question, but I'm not sure of the answer to that question. I think it's a fairly new technology. I know that as far as commercial buildings go, the new Austin Public Library, which is now currently closed, they're utilizing gray water in their toilets in that building. I do not know what the GPF of those toilets is, so I'm really not sure of the added filtration. Any filtration would help with gray water, but I think it's a great technology, and I can certainly do a little bit more investigative work as far as what filtration is required. But I think it's a fairly new technology in toilet flushing at this point. So, but it's people are beginning to develop new, more affordable technologies in gray water. So I can't really answer that question as far as specifically what filtration systems required for it.
Besides the WaterSense and the MAP certifications, a lot of folks in these sustainability projects are looking at, where materials are coming from, what they're made out of. So we know the Living Building Challenge leads the way with something called the Red List, having, less toxic materials in the products. Do any of these technologies you've been referencing have Red List approval or are working towards that, or what are the challenges there?
Yeah, definitely some challenges. We've recently gone through a little exercise with this. Hey, Holly, you're still on, right?
Yes.
Yeah. So
we do you want me to? I can speak to this a little bit because we here at Niagara went through this with the Living Building Challenge, and I think that every manufacturer is going to be different as far as what product what they use to manufacture their products. But we found even with our own products that we were close to meeting all of those on the Red List standards, I guess, as far as not having those, but it's certain parts that are within a toilet. So like Fluid Master is a big brand that does the flush valve, and they use like formaldehyde or trace amounts of formaldehyde. So I think it's going to be a challenge, but that sustainability and that transparency is becoming bigger and bigger for us as manufacturers to help prove. And so I do expect that we'll try to find alternative solutions. So I guess to answer, that most toilets should meet that Red List. If but there are a few minor details within, parts that are used within tank technology that could have, a few chemicals not included.
It's a work. Yeah, definitely. Thanks, Holly. It's a work in progress. Is what it is right now, as far as like determining if there's other materials that can be completely formaldehyde free, et cetera. So, there's a lot of plastic parts and other things in toilets that make them work that way. So, yeah, definitely something we're working on and continuing to investigate and study what other materials we can use, perhaps in the manufacturing of the toilet to, even reduce what little bit is there currently. So.
Earlier, you brought up pressure-assisted technology, and I recall maybe a year or two ago, I saw a huge recall on some pressure-assisted, I don't know whose system it was.
Yeah.
I mean, it seems like it's a concerning technology, which seems to be used on most low-flow toilets. What are your thoughts there?
Yeah, I've heard the same things. I mean, I've heard a lot about maintenance issues and things like that. I think they're high maintenance type product. And I don't know if it's because of the introduction in the air at the top of the cylinder that helps push the water, but they're very loud fixtures and they do require quite a bit of maintenance. The vacuum assist, on the other hand, because it's just air in the trapway of the toilet, pulling that air through the air transfer tube and forcing it back down, it's a pretty simple movement. There's not a lot of complication in that. So it's a very, very low maintenance product. Actually, if it's appropriate, I can actually show the flush tower, and I'll show you what really acts as the flapper of the toilet if anybody still has a couple more minutes.
Yeah, why don't you do that?
Yeah, that'll help explain the actual mechanism within the toilet that keeps the water from going into the. So am I set to show the tank?
Yeah.
And I'll do the best I can remotely here. But I mentioned to you this is a clear tank demo that we use at trade shows and such. But the first thing I want to show is the bottom of the tank of the toilet. It's a typical, from a plumber standpoint, it's a typical install. You can see those two holes. That's where the bolts are going to go. They're going to attach the toilet to the tank to the bowl. The only additional connection is this air transfer tube. So you can see the back. And I have a little glare, I apologize, but you can see the air transfer tube that's on the back of the flush chamber. But from a plumber's perspective, everything is already installed. All this tank trim is pre-installed at the factory. So it's just a matter of pulling the tank and the bowl out of the package and attaching the toilet to the floor and the tank to the bowl. This is your fill valve, obviously. But it is the importance of this connection. This gasket actually comes with too, and that's pre-installed as well, that there's a gasket on here. But it's important, the integrity of this connection is important. Doesn't take any extra time to do it, but that flow of air is very important to the power of the flush. And I just want to show inside the tank side real quickly. That's what the inner mechanism looks like. That cylinder in the middle here is where the 0.8 gallons of water resides that's used in the flush. The fill valve I mentioned fills from the bottom. You can see that right here. But the last thing I want to show you is that flush tower, right? So this is a quarter turn on the tower. Pull that so you can see how the water is going to flow from the tank into the bowl out of that chamber. But this cylinder has at the bottom of it, so this is how it works in the toilet. So when you hit that flush button at the top, it's going to raise that, and then it's going to drop it back down when the flush is completed. But this little seal I keep moving the wrong way, everything's mirror image. This little seal is what acts as the flapper of the toilet. So that is going to keep the water from flowing from the tank into the bowl. The key to this is that it is compressed under hard plastic. all the time unless it's flushing. So it's much less likely to leak or cause problems in a flapper toilet. These are very, very low maintenance toilets. We have many customers that have had these toilets since their inception back in, 8, 9 years ago, that have never even lifted the tank lid off the tank to look at this. I mean, it's very, very rare. So this is a super low maintenance technology. That's another benefit for your owners. Very minimal maintenance. You don't have to worry about changing those toilet flappers out. So this technology compares very favorably to pressure assist as far as the maintenance goes.
Great, thank you so much for that that very helpful demonstration. And
Yeah, thank you.
what I've been hearing and personally experiencing a lot of backlog trying to get products. How are you all holding up? I mean, as far as the pandemic, and is supply still going, or is it slowed? Or
No, we have a very consistent supply. We had a short shutdown in factories for a very brief period of time, but they were right back up. We're actually experiencing, we experienced more supply issues a couple of years ago than we're experiencing right now. So these stealth toilets are readily available. We have a good inventory. All of our inventory is either in Dallas, Texas, or in Torrance, California, that serves the West Coast. So we've got good inventory and good availability on these products right
now. One last question came in before we wrapped up, from one of our members, and it's actually more of a comment and a question, so I'll read it. My family has one of your 0.8 gallon per flush toilets and loves it. In our attempt to further save water, we sometimes gather the water that would otherwise be wasted while waiting for a shower to warm up and use it to flush the toilet. We use this by removing the tank lid, flushing the toilet via the button, and pouring the water into the tank. Is this okay? Is the flush as effective as if it's a toilet filled through the fill valve? Any more comment on that?
Shouldn't be a problem, as long as and that's fantastic, because that is one of the big wasters of water, is waiting for that shower to warm up, especially in the winter time, when you need a warm shower. Yeah, and they say you should put a 5-gallon bucket and collect the water and reuse it for, whatever it is, watering plants, flushing your toilet, whatever. So as long as the convenience isn't a problem. Just so when I showed that tank earlier, there is a fill line in the inside that chamber. So in order for the toilet to work very effectively, the water just needs to be up to that fill line. If there's not enough, if it's 0.6 instead of 0.8, it's not going to flush as effectively. Just like the air transfer tube connection is very important, because that air transfer creates the power of the flush as well. So no, nothing wrong with that, as long as it's not too inconvenient for you. I think it's a great way to continue to save water. But pay attention to that fill line. As long as it's filled right up to that fill line, your toilet should work just as well with the water from the shower as it would if it was filling from the bottom of the fill valve.
Yeah. We'll have to get you on.
Cool. I like that.
We'll have to get him on for do-it-yourself gray water.
Absolutely, do. I do like that. Yeah. Really cool.
All right, Richard. Well, I don't see any more questions. I thank you for sticking around a little bit longer. Sorry for some of those technical difficulties. Before we wrap up, where can people go to learn more, contact you if they want to reach out?
Yep. My email address with Niagara is rrossi, RROSSI @niagaracorp.com. You can go to our website at niagaracorp.com to learn more about our toilets. We have a very thorough website explaining what we call on market as the stealth technology, which is the vacuum assist technology. So there's some very thorough explanations and brochures available that you can download, which illustrate exactly what I showed you, the whole flush process from the air being forced down into the trapway to being removed and the tank refilling and forcing the air back down. There's on YouTube, if you Google Niagara's YouTube channel, we have some nice short 2-minute videos that actually show that flush process happen, which is really cool. an animated version of it. So it really does go far to explain the technology. And then for designers and architects out there, we have downloadable files for each model of our toilets with stealth technology in them. So it's a very accessible and easy to use website where you can download specs, you can download 3D drawings, etc.
Great. Well, Richard, we thank you so much. Thanks to Niagara for your support. And real quick, just, we were talking about this before the session began, but we really selfishly do want to see you all eventually in person. I know we're going to keep doing our webinars forever, but we want to see you all. So you got to stick to the, staying in when you can, wearing your masks. We're going to beat this thing, and we're going to see you all in 2021. So thank you so much, everyone. Take care. Have a great rest of your week.
Yeah, all right. Thank you so much for your time. Appreciate it. Take care. Stay well. Thanks, Brett.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.